everyone, let's get started. Welcome to DSC 10. This is the summer of 2022. In case you're like me and forget what year it is. If you're not here for DSC 10, then I hate to tell you this, but you're in the wrong classroom, so you should probably go and find your classroom. This is the classroom we're going to be using for DSC 10 for the whole summer. So our lectures will happen in here, and you'll take your midterm and final in here as well. DSC 10 is like a guided tour of data science. So it's the first course that a lot of students take at UCSD in data science. It was originally designed by Berkeley, and it was adopted by UC San Diego in 2017. So this course has been running for like 5 years now. The instructors for this course have really iterated a lot on the contents. They put their heart and soul into the material of this course, and I'm really excited to be teaching it. So I'll give you a little bit of background about the course. I'll tell you about myself and what's happening, and I'll tell you a little bit more about how the course is structured, and then we'll conclude today with the demo. In this course, you'll learn programming and statistics. We don't have enough time in this course to go really deep into programming or statistics, and we'll leave that to more advanced courses in the DSC program. But this course gives you enough programming and statistics to get you up and running to start doing your own data analysis. The statistics, in case you're concerned, is not too much math in this course. Instead, we're using what we call a simulation-based approach, where instead of learning about instead of spending a whole lot of time on probability and rolling dice, we'll use simulation and we'll use the computer to work with statistics in this class. All right. So as I mentioned, I'm going to talk a little bit about myself and the course staff. I'm going to talk a little bit about what is data science, talk about how this course will run, and I'll give you a little demo and give you a taste of what we're going to do for the rest of this course. My name is Sam. I'm a PhD in Cog-Sci at UCSD. I study human-computer interaction, and what that essentially means is I'm like a glorified UX researcher, and I make interfaces for people to use. My research is in tools for teaching people data science. And one of the tools I'm really excited to try out with all of you this summer is called Pandas Tutor, and it draws diagrams for you to help explain your code. So this class is also a little bit of a research experiment for me. I'm going to be using your feedback to kind of guide the development of this tool and hopefully make it really useful for students like you and for instructors all across the world. I did my undergrad and master's at UC Berkeley. I studied electrical engineering and computer science, which is a long name for basically just computer science. I didn't really do double E at all at Berkeley. At Berkeley, I worked on the original data science courses. So the course that DSC 10 was based off of is at Berkeley called Data 8. I was part of the original course staff to develop that course, as well as other courses at UC Berkeley around data science. And so I've been teaching data science for a long time now, maybe 6 or 7 years. I'm really excited about it. Every time I teach it, I just get really happy because I get to meet students from all kinds of backgrounds and different places. And I'm also working on a textbook called Learning Data Science. It's a more advanced textbook, so if you take a course like DSC 80 here at UCSD, you may use some material from it. But right now, I'm still working in development on it. All right, talking about course staff. We have a few other staff members who are here to help you out. I should take out discussions since we won't have discussions in this class. I'll get into that later. But the course staff is here to hold office hours and answer questions on Campus Wire. My TA, Shivani, is sitting in the back. Can you wave hello? So Shivani is a master's student in ECE. Yeah, that's right. And she has a lot of teaching experience too. She really enjoys teaching. And she's going to be our one TA for this course, since our course is pretty small this summer. We have 3 tutors, Eric, Oren, and Tiffany, who if you go to their office hours, you get to know. And on our webpage, we have little blurbs about them, and you can try to get their picture and see what they look like. All right, so now I want to know a little bit about you. I want to ask if you have any programming experience coming into this course. So we don't require any programming background for DSC 10, but I'd just like to get a sense of what you're coming in from, and also to try to get you to try out using this tool called Menti, which is a tool that we'll use in class to answer questions. Just a quick show of hands, how many of you have used Menti before for some other class? Okay, so just 1 or 2 people. To use Menti, go to menti.com on either your laptop and phone and enter this code on the screen. Let me make sure that the thing is right. So, present this. Okay, so it should be up there. Let me know if there are any problems with it. If you go to menti.com and enter in that code, it should allow you to choose like a multiple choice question, A, B, C, or D. So please answer according to your level of programming experience. All right, let's see how they look. Listen, we have some answers coming in. Okay, we'll give you 30 more seconds for that. All right, so it looks like we have 3 people with a lot of experience, a lot of people with a little bit of experience. No one answered that they don't have any experience at all, but if you're like me and like taking my first programming class, I was like really scared to admit that I didn't have programming experience. So if you don't have any programming experience, I just want to say it's all good. The course is made for like people like you. So if you're here and you have a lot of programming experience, then honestly, it may be like, okay, some parts of this course are a little bit too easy. So I just wanted to say, if you're here and you're like, I don't really know too much about programming, or I know a little bit, but I don't feel like confident, like this is the right course for you. Okay. So what is data science? If you Google data science, you get like all sorts of different descriptions and images and blog posts, and you get like you get like HBR, Harvard like business school articles about how data science is going to like revolutionize some enterprise industry, and you get a lot of buzzwords. And honestly, if you're like me, you Google this stuff and you're like, I don't really I get that people are excited about it, but I don't really know too much of what it is or what it really means and why people are excited about it. The thing about data science is that everyone has their own definition of it. So some people think that data science is just like making plots. And other people think that data science is like working with Excel. And other people think that data science involves like writing like tons and tons of like machine learning code. And the truth is that the real definition of data science is still like a topic of debate among most people. If you go to different companies and you like apply for data science positions, they have many different requirements for what they expect from a data scientist. And that was true 5 years ago, and to my knowledge, that's still true today. So people don't necessarily agree. In this class, what we're defining data science as is drawing useful conclusions from data using computation. So what that means is, in this class, we'll take data sets. We'll take data sets like, for example, COVID-19 cases in San Diego, and we'll use computation to draw conclusions from them. So we'll use the Python programming language to try to like figure out, to answer questions that we have about the data. So we might want to know, when was COVID-19 worst at UCSD? Or when was it least bad? Or when was like the cases rising the quickest? And those are all questions that we can answer using data. The reason why people really like data science is because this data science practice of drawing conclusions from data is something that's really broadly useful. So city planners use data science to figure out where to build new roads or where to repair like holes in the roads that are there. Medical people use data science to figure out whether a vaccine is effective. Political scientists use data science to measure, for example, to take a guess at how many people will vote for a particular candidate in the election. So the world today, the way I see it is that a lot of decisions in the world today we make using data. And knowing how to do data science is just a broadly applicable skill for many fields that allows you to just like tell someone, hey, like we want to make a decision about A versus B, and here's my evidence, and here's the argument for why we would choose one over the other. In this class, we'll learn about three core components of data science. One of those components is exploration. So we're going to look at data sets, we're going to draw plots, and try to understand more about the data that we have. Another core component is prediction. So we can use past data to predict future data. I can use the weather from yesterday to predict the weather today. And I can use the weather from last year to predict the weather in San Diego this year, which is probably like pretty good. That'd be my guess. And the third pillar of data science is inference. In inference, what we're trying to do is take a limited data set, let's say a data set of 100 voters, and use that limited data set of 100 voters to make a guess about the population as a whole. So we can use small data sets to draw conclusions about really big groups of people using techniques from statistics. As an example, data science today is kind of in vogue. It's becoming popular, and one of the reasons why it's popular is because of COVID-19. And COVID-19 is, as you know, a pretty big deal. And people have like created all sorts of dashboards and plots for tracking the number of COVID-19 cases over time. One of those plots I pulled from the New York Times yesterday. This is like the plot of just the number of cases over time. So you can see some spikes around when COVID-19 first kind of came into the scene in 2020. And then another huge spike when Omicron came into the scene in this year. People nowadays need to interpret data and need to make decisions about data all the time. So here's an interesting plot. So this plot here, what we've done is this Tutor user put the number of COVID cases in blue on the bottom here, and then in red is a number of bad reviews of Yankee candles on Amazon saying they don't have any scent. Okay, so just take a minute to like look at this plot and think about why this might have happened. Okay, so if you're like me, you're looking at this plot and you're like, well, like we know that COVID-19 kind of messes with your sense of smell. So people who got COVID, if there are a lot of people who have COVID, they would probably light a candle and then think, this candle doesn't really smell that good. There's something wrong with this candle. So they post a bad review on Amazon. And so, we don't know if this is necessarily what happened, but the correlation is a little uncanny. It's just funny to think about. Okay. Data science has social implications too, because a lot of the tools and systems that we use in day-to-day life use data science. One example is this tool called a face Depictionizer. This tool takes pixelated images of people and generates images that are more detailed. So let me zoom into this picture here. So this machine learning model takes in this input. So we give it this picture that's very blurry and like you can't really make out any detail. And the program will add detail to the picture. So this face never actually existed. It's the program's like guess for what the original face looked like. And that's cool and all. So let's take a look at this example. So on the left here, we have a picture of a famous US president named Barack Obama, and we gave this blurry picture to the machine learning model. And the machine learning model made this picture as the output. Let's take a look at that and try to think about why that might have happened. Okay, if you have an idea, turn to your neighbor and just give him like the one sentence pitch of what you think happened. Go.
When training the model, there will be enough images.
Okay, just a little quick discussion. I heard some good responses. So when the people who programmed this, who made this program, created this program, basically, they gave it a lot of pictures of examples of faces, and it turns out that a lot of the example pictures they gave the program were people that looked like the person on the right-hand side, and not so much people that looked like the person on the left-hand side. So even though we look at this picture with our human eyes and we immediately recognize, oh yeah, that's Barack Obama. The computer just thinks, oh well, everyone I know looks like this person on the right, so I'm just going to take a guess and make it this person on the right. It's a caveat of a lot of like AI or machine learning systems, and you'll hear examples of that if you've heard of like chatbots on Twitter that go kind of crazy and become racist. Like that's pretty much what happens to them. So understanding how these things work is part of like the reason why we have courses like this, and it's to help you understand, okay, well, these things that are magical, quote unquote, like AI or machine learning models, really what they're doing is they're making predictions about the future, but we have to tell it like what we think the future will be. All right, let's talk logistics. Course website. The course website is like the one place that you should bookmark when you have questions about what's happening next in the course. The website is dsc10.com. We're going to post lectures, we'll post homeworks, and all other content for this course. So I really suggest you check it often. It'll be updated nearly every day that we have this course this summer. And do be sure to read the syllabus for questions about course policies and grading and stuff like that. We're going to go over a lot of the logistical content of the course right now, but the full details are in the syllabus. So I'll kind of run through it quickly, give you a high-level summary, but for the full details, you should really look at the syllabus and then ask us if you have questions. Okay, so there are a few accounts that you'll need to have as a student of DSC 10. The first one is CampusWire. CampusWire is a Q&A forum, so you can post questions there and get answers. Right now, we're still getting everyone like on the rosters into our systems and getting them accounts. So you won't have an invitation to CampusWire yet, but you should receive one by the end of today. And if you don't get one by the end of today, shoot me or Shivani an email, and we'll make sure that you can get onto CampusWire. Same goes for Gradescope. Gradescope is like a website that we use for grading assignments in this class. So when you finish the assignment for the class, you'll download the assignment and then you'll send it to Gradescope. And Gradescope is a system that we'll use that will automatically grade your assignment, tell you how many points you got, and it records the grades in our system too. Again, the accounts for CampusWire and Gradescope are not out yet, so they'll come out later today. And if you don't get one later today, let us know right away. Datahub is the tool that we'll use to access and run all the code for the class. The URL for Datahub is datahub.ucsd.edu. I'll show you how to use Datahub later on, I think on Friday. But for now, you can just keep this in mind and know that you'll be visiting the site a lot for this course. Note that we won't be using Canvas for anything. So if you didn't get an email about being added to Canvas, don't worry about it for now. Just make sure you get emails for CampusWire and Gradescope by the end of today. We won't be using Canvas for anything, basically. So the grades for your assignments will be on Gradescope. Q&A discussion will be on CampusWire. The podcast for this course will be on podcast.ucsd.edu, and we won't post it to like the media gallery of Canvas or anything. We just don't really like Canvas in the DSC program, so we just hate on it and bash on it. So we just use these. We use these other tools instead. Okay. We have a survey to fill out, the beginning of quarter survey. I think it's probably best if you just keep that in mind for now, and we'll send out an email later today about the survey, so you can fill it out. The survey just asks some questions about your background and whether you how often you plan to come onto campus, so we can plan out when to have in-person office hours. All right, talk about lecture. You're in one right now, and they will all be in person. So every Monday, Wednesday, Friday at 11, you'll see me up here. They'll be all podcasted for viewing afterward. So attendance is never required. I'm never going to be here and be like, ah, yes, like James is not here today. I'm going to give him an F on this assignment. So I won't. It's all good. Like you have busy lives, and if it's more convenient for you to watch it remotely, like just do that. I'll also post the slides and code from the lecture on the website. And one note about the course schedule is that we won't be using the assigned discussion or lab times. So I know on the UCSD schedule, it says that we have like 11 to 12 a.m. meetings every day of the week. But the discussion and lab times, which are Tuesday and Thursday, we won't be using at all for anything in this course. So the only actual class meetings are Monday, Wednesday, Friday. And instead of having discussion and lab times, we'll be having office hours instead. So the rationale for this is essentially like, before we used to have discussion and lab and hold those at like set times every week. But then people who came into those class meeting times essentially just wanted help with their homework assignments anyway, and it ended up becoming office hours. So because of that, we decided to make everything office hours and just try to get you to help that you want instead of having like a set, like we have to go through this discussion worksheet. So since it's, especially because it's a small class, I suggest you just come into office hours and we can just give you personalized help for whatever it is that you're personally struggling with. Okay. So if I was a student and I was looking at this, I would be thinking in my head, okay, great. I'm just gonna go home and like just stay home and chill out all summer long and never come into class and just like lay in my bed. And if you're like me, then like you do you, and that's great. Yeah, I just wanted to. Well, for me as an instructor, it's like I have to come here whether or not anyone shows up, right? Because even if one person shows up, if I'm not there, they're going to be like, where the heck is Sam? So it's in my best interest to try to make lecture entertaining and engaging for you so that you feel incentivized to come out and like attend. So my suggestion to you is just think about whether you learn better when you come in lecture versus watching a podcast. Like, what's the best use of your time? If you feel like you can learn the material really well watching me talk 2 times speed, like that's great. If you feel like you'll learn better when you come into class and have to like, I don't know, watch me step through slides and code and like be able to ask me questions, and that's great too. So I just give the option open to you, and I just want you to think about like, okay, like how do I make the most out of my summer? How do I make the most from this course? Cool. We have weekly lab assignments, and these are shorter assignments, so they hopefully shouldn't take more than a few hours per week. And the idea behind lab is essentially to just practice what we learn during lecture. Lab assignments have auto-graded tests, and what that means is that when you write code for these assignments, we'll tell you you can run some code, and it'll tell you right away whether your solution was correct or not. The key thing to remember about labs is you'll be able to see right away whether you got your question right, and if our tools tell you that you got every question right when you submit your lab assignment, then you're guaranteed to get 100% on the assignment. So even if like something goes wrong with our system and you get like a 90% when you ran it on your computer and you got 100%, you can come to us and tell us, and we'll be like, okay, let's fix your grade, let's get you the full credit for the assignment. So labs are meant to be like practice, they're meant to be low stakes. They're not meant to like have any trickery or anything. They're just meant to help you feel like, okay, I have practiced doing what we learned in lecture, and I can do this later on this week. Okay, labs are individual, but you can feel free to discuss ideas. You just can't copy and paste code. And labs will be due Saturdays to Gradescope. We'll be releasing the first lab either later today or tomorrow. It'll be due on Saturday, and it'll have submission instructions in the lab. So we'll go over that later on this week. But just keep an eye out for the first assignment.
Quick question.
Yeah. What's your name?
The lab. Oh, Ethan.
Ethan. Hi.
So the assignments, where would we how would you send it to us? Like, where would we find it?
We'll give you instructions later on.
Oh.
Basically, what we'll do is we'll put a link to it on the course website. It's a magic link, so if you click that link, you'll get your own copy of the assignment automatically on your computer. Okay, let's talk about homeworks and projects. So homeworks and projects are a little bit longer than lab assignments, and they're meant to build your knowledge, like give you a lot more practice and build your knowledge for stuff that maybe extends what we've done in lecture. The main difference between homeworks and labs is that when you pass the tests for the homework, it doesn't guarantee that you'll get a perfect score. Okay, so you do have to keep this in mind when you're working on homeworks and projects. On labs, if you run the autograder test on your lab and you get 100%, you're guaranteed to get 100% for that assignment. Homeworks and projects will have secret test cases that we'll use to just do more thorough checks of your code. So you have to be more responsible and try to make sure your answers are correct before you submit these homeworks and projects. Okay. Working together on homeworks is all good. You can sit next to someone and work together. What I only care about is that you don't just copy and paste code because you don't learn too much stuff with it. Homeworks will be due on Tuesdays. Okay, so labs due Saturdays, homeworks due Tuesdays. There'll be 2 projects for this course, a midterm project and a final project. Essentially, these are homework assignments, but they're a little bit longer. So you have to make sure you budget more time in your schedule to finish these 2 assignments. Another difference about projects and homeworks is that projects you can work together with someone on one single copy of the assignment instead of working on 2 separate copies. And you can use pair programming for that. So you can just work together really closely with someone on these longer assignments, and we'll give you some, and you can find someone to work with because the assignments are longer. All right, exams. We have 2 exams. The first exam is the midterm, and it'll happen during lecture. So it'll be Friday, July 29th. It'll happen during lecture from 11 to 11:50. The final will be is scheduled for the course from it's set by the campus registry, and it'll be Saturday, September 3rd, from 11:30 to 2:30. Both exams will be in person and on paper. So if you're planning to attend everything in the course remotely, that's great. Just make sure you come in for the exams because I don't want someone coming in and saying, hey, I thought the exam could be remote too. Where is my exam? Oh, one more thing about these exam times. If you have a conflict for one of these times or both of these times because of another class that you're taking this summer, we'll have a form out for alternate times. So keep an eye out for the form. If you do have a conflict, don't worry about it. We'll find a time that works for you, and we'll just make sure that you have some time that works well, that you can take both exams for your classes and not stress out about conflicts. Okay. We have some readings and resources. The readings won't be required, so we won't be like, did you read the textbook today? And we won't be checking whether you read it or not. They're meant for you to just have a resource. So if you feel like watching a video is kind of hard to review the material and you don't like figuring out where exactly I talked about storing a data frame or something, you can look at the course notes and it's a little bit easier because you can search through it, you can scroll through it, and you read a little bit faster than you can watch a video. So we have these resources and we'll post them on the course website, and I think they're already linked up on the website. One of them is our personal DSC 10 course notes, which the past instructors at DSC 10 have written up themselves for the course. Another one is a book called Computational and Inferential Thinking. It's a textbook made for the Berkeley version of the course, which means that it has some differences between what we're teaching in this course. So that's why we're not using the Berkeley textbook for everything in this class. We're using a combination of the 2, and we will, on the course website, we'll show you which pieces from each book to read for each week of the course. All right. We have more resources, so I just want to give a shout out to the resources tab of the course website and the debugging tab of the course website. All right, so again, just to give you a little mental model of what the schedule for this course will be like. Monday, Wednesday, Friday, lectures for this class. Tuesday, Saturday, assignments due. And the first lab will be due this Saturday. The first homework will be due on Tuesday of next week, not tomorrow, of next week. So what we're planning to do either today or tomorrow is release both the homework and the lab and make them both available so you can start working on them as soon as you'd like. But I really suggest you work on the lab before the homework because the lab will kind of teach you the basics of how to work with the technology that we're using for this class, as well as the basics of programming, which we'll build upon for the homework. I also do suggest you start early. If you don't start early, you'll learn the hard way. that it's pretty hard to like try to do an entire assignment in one day. So especially if you don't feel as comfortable programming, what I would suggest you do is, even if you have like a busy schedule, is what will help me as a student is I would open up the assignment and just scroll through it and just get a sense in my head, okay, this assignment is really long, I should probably like budget some more time for it. Or I would look at the assignment and think, okay, the assignment doesn't look too bad. I can work on my other classes first and then work on my assignment. So I would really suggest that when we post the announcement saying that our assignments are out, that you just open it up, take a peek at it, and then you get a sense of like, okay, I should dedicate a lot of time, or I don't have to dedicate as much time. This course is actually pretty tough. I don't actually know too much about how the word on the street is about how hard this course is, but I would say this course does require a significant amount of time commitment. You'll be spending a good amount of time like trying to figure out how to make your code work in this class, and so it won't be a breeze. It won't be a walk in the park, and you should expect to have to spend like several hours per week at least working on the assignments. That being said, we really do want to make sure that you have a good time and you're not just like, oh my god, this course is a full-time job. So we do want to help you out, and we'll do that by having office hours. We'll be having some remote office hours and some in-person office hours throughout the week. We can answer questions on CampusWire, the Q&A form. So if you have a question and you can't make it out to office hours, you can try to see if a staff member or another student will answer a question for you there. One thing about CampusWire is that if you post code there, you can post your personal code if you make your code private. Usually what we suggest you do is you post like maybe like a really short summary of your idea rather than posting your code like word for word, just so that no one else in the class just copy and paste your code and takes credit for your hard work. Okay. We looked at some of the student responses from the fall quarter of DSC 10, and we took the ones that we felt like captured like the most common advice that previous students gave to current students of DSC 10. So here they are. Go to office hours. Get a partner for the project even if you don't want to. If you don't understand a topic, try to go to office hours, ask CampusWire, check the textbook, look at lecture notes, start assignments early, and try to aim to finish 2 days early to check your work. Okay, another student wrote, attend discussions in office hours. I can't do that because we don't have discussions, but attend office hours. It's hard to catch up when you fall behind because we have a lot of content per lecture. So this lecture will seem pretty chill, but you'll find that like starting on Wednesday or Friday of this week or so, we're going to really start ramping it up and put a lot of content in each lecture. So I do really suggest you keep up. Okay, we're gonna take this advice out this summer, but we will try to re-explain concepts to you during office hours and give you help there. Okay, go to office hours. Yes, I recommend this. Okay, so collaboration. This is just you ask questions. I know it's scary. Like I was a student, I never wanted to admit that I was dumb because I thought I was really smart, but it turned out I wasn't that smart after all because I kept making mistakes on my programming assignments. So I would really suggest if you have a question about anything, even if it feels dumb, you just go ahead and ask us, and we're just here to help. So we're not going to be like, oh man, like Sam is so dumb. He just keeps misspelling his code names and stuff, and he's whatever. He's a bad student. Like we're not really like that. We're just trying to help you out, and whatever you're stuck on, we just want to make sure you get unstuck. With your fellow students, you can feel free to just discuss anything you want, except for during exams, of course. So if in class you have a question about something, I don't really care if you just turn to your neighbor and be like, okay, hold on, like what does Sam actually say about this? And I don't mind. So if you have a question and you just want to ask your neighbor while I'm lecturing, it's all good. Like I'm pretty chill about it. The only caveats for assignments is just don't copy and paste code. That's basically it. But you can work with other people. I don't really care if you like work next to them. Like really, it's the assignments are just for you to practice. And the important thing about the assignment for me is not whether or not you like finish it or get a great grade on it, but it's really whether you get to practice and you feel confident about about doing data science. All right. The one caveat is projects. So projects is okay to like take your partner's code and move it to your computer and then work with it and then move it back to your partner's computer. That's fine. But otherwise, like everything is great. You can look at your partner's code for like ideas, but just try not to like copy and paste it word for word. Okay. I think that's about it. Do I have anything here about integrity? I don't have anything about integrity. Okay, so I'm like obligated to say that like cheating is not allowed, and that if we catch you cheating, that we'll have to penalize you, and we might have to report you to like the I don't know, central school thing. To be honest, like I do not want to spend my time just trying to like really dive into your code and figure out whether like because you named two variables magic, because you and your partner both named variables Magikarp or something, that like you copy and paste your code. Like I'm not going to do that with your code, and I'm not going to have my staff do that either. So all I want to say is like, if you're taking this course and the content is interesting to you, then I'll just put you in charge of your own learning. So I consider you all like adults and peers, and what I would really hope you do is just take stock of like, okay, if I'm falling behind this course, I can talk to Sam, and we can work something out, and we can like do something with the assignment. And things come up in life, right? Like people get sick. You might get sick. Like I got COVID a few weeks ago. It was pretty miserable. I don't know. Like stuff happens with family. Stuff happens with your job if you're working like an outside job besides and doing school at the same time. So like we're used to it as instructors. We've kind of seen like the whole spectrum of like people who've had like really crazy disasters happen, and people who have like smaller disasters, but like things that still stress you out. So yeah, I just wanted to say that like we're just here to help. We're not here to like be a police, and we just hope that you have fun with the course. That's what we like. Okay. Again, I just want to reemphasize that we don't expect you to have any programming background or statistics background. So if you're like me taking my first programming class, you're going to look at if you're kind of newer to programming, there'll be some point in the course where you're going to sit down and you're going to think, man, I just feel like everyone in the course is doing, like just having a breeze with the assignments. I know one person who like finished the assignment in like 30 minutes. Why am I stuck here for like 5 hours on the same problem, and I feel really stuck and I feel really dumb, okay? What I really would suggest is, like, just know that people who have a lot of experience, they're not necessarily better than you or smarter than you. A lot of times it just happens because people have taken other programming classes before this one, and because of that, they're having less of a difficult time on the assignment than you. Everyone who learns programming has to struggle with it. That's kind of the deal, and the difference is not really like whether people are smart or dumb, or whether they think that they're a math person or not. There's a lot of research that shows that like really the biggest like factor that comes to people like feeling like they succeed in a programming course, or how like confident they are in programming, is their background. So people who seem to be like having a breeze in this class probably just have more experience and more previous, like they've seen this stuff before. But if it's, in that case, if it's new for you, what I wanted to say is like, it'll be hard because it's new, but it was hard for everyone at some point. And I would really hope that if you're feeling discouraged, you can just come talk to us and be like, hey, like, I feel like I'm falling behind, and we can just give you like an accurate gauge about what's going, like how you actually stand in the course, what we think of your knowledge, and what you can do to improve and get better. Also, this summer might be the smallest DSC 10 course for the foreseeable future. So the course is pretty big in a normal school quarter. I think it ranges between like 1 to 300 students, depending on how many people want to take the class. So I honestly think like this class right here is probably going to be the smallest DSC 10 class, maybe in the next 5 years, maybe the next 10 years. Who knows how long? And because of that, what I like to do as an instructor and what we like to do as like instructional staff is just try to get to know you, since there's not that many people in the class. We'll try to learn your names. We'll try to learn about like your background, like what you're good at programming, what challenges you have in programming, what things you might be best at. We'll just try to get to know you and try to make this class feel like a small class, even though we go to a really big public school. Like there's opportunities, there's like rare opportunities in a large public school like UCSD to have a small class experience, and I think this is one of them. So just wanted to pitch that for you, and I hope that you can take advantage of it, because it might not happen often if you keep taking DSC classes or other technical classes that are really big and really popular. Okay, let's see, how many on time? Got some stuff. Okay, we got about 8 minutes left. Let's do a little demo. I'd like to show you a little bit the type of code that we'll write in this course. You're going to look at this code and it's going to, if you haven't programmed this way before, it'll seem really unfamiliar. My point is not to intimidate you. My point is just to give you a taste of what you'll be able to do by the time you leave DSC 10. So what we're going to do today is we'll look at the book Little Women. Can I just get a quick show of hands? How many people have read Little Women? How many people have heard of Little Women? Okay, heard the name of the. Do people know there's a movie, Little Women? I didn't know that. Okay, yeah, I didn't know that either. But someone pointed out to me earlier, and I didn't know. Little Women is kind of like an antiquated book. We used to read it for school and stuff. I don't know if it's like popular anymore. But in either case, it's like a classic. It's like a classic novel about like four sisters: Meg, Jo, Beth, and Amy, and kind of like their lives growing up and the things they do. And what we'll do is we'll use some code to learn about this book, even though I don't think any of us have read it. I haven't even read it, actually. So what we'll do is we'll use some code and we'll try to learn some things about this book without needing to read through all like several hundred pages of however long this book is. Okay. So don't worry too much about what code I'm writing. I'll just try to give you a high-level idea and just try to sit back and just look at like what we can do, what's possible with writing code. Okay. I have a bit of code here that reads the entirety of the novel into Python, my programming language. If I look at the book, I can look at the first 300 characters of the book, and you can see that it has some text here. It's a little bit short, so let's make it longer. Okay, so you get a bunch of text. It's kind of illegible, so we can try to make it easier to read. All right. So what we've done here is we've read in the entire book in like a fraction of a second into Python, this programming language that I'm using. The entire book is here, and if I scroll down here, you can see the title here. Let's look at the contents here. Let's scroll down and try to see where the book actually begins. So there's like 47 chapters, and here's chapter 1. Christmas won't be Christmas without any presents, grumbled Jo, lying on the rug. It's so dreadful to be poor, sighed Meg, looking down at her old dress. And so we see that the text is here. If we wanted to read it in like a crappy formatted text, we could just scroll down here and read the entire book, but I'm not going to do that. So what I'm going to do instead is I'm going to look at how often these people were mentioned in the book. So let's go here. And let me run this code here. Oops. I have to run. Sorry. I have to do this. Okay, let's go back. You'll see me do this a lot. I make a lot of mistakes, but here we go. Okay. So what I've done here is I've taken all the chapters of the book and put it into what we call a data frame. A data frame is just a fancy word for a table of data. And so what I've done here is I essentially made like an Excel spreadsheet in Python. So every row in this Excel spreadsheet is one chapter of the book. So we have chapter 1, chapter 2, all the way up to chapter 47. Ooh, this is not the right notebook, right? Let's see. Let's go here. Okay. Okay, so we have twice. Sorry, I was working with like the filled in version of the notebook, but I was supposed to type in this code so that I could just show you what it's like to type in code. Okay, so this is right. So we have some blanks here. What I'm going to do now is I'm going to count up the number of times each person was mentioned in the book. So I can write with a little bit of code. I can count up the number of times Amy appears in each chapter. And I can do the same for Beth, Joe, and Meg. So let's do that here. Beth, Joe, Meg. This is a lot of what programming is. It's just copy and pasting. So you'll see me copy and paste a lot, and that's pretty accurate. Like a lot of times you'll be copy and pasting too. Laurie is the name of a boy. And we'll see that in chapter 1, Amy was mentioned 23 times, Beth was mentioned 26 times, Joe was mentioned 44 times. So we have how many times each person was mentioned in each chapter. What can we do with this information? What we can do is count up the number of times each person was mentioned across the entire book. Okay, so we can do what we call a cumulative count. And again, don't worry too much about what I'm typing. Basically, what we care about here is that like this part of the code right here just says count the number of times Amy appears. Okay, so we're just counting the number of times Amy appears, and then again, oops, I'm going to copy paste, do Beth, Joe, Meg, Laurie. Beth, Joe, Meg, Laurie. Let's take a look at what we get. So what I've done here is I've said, okay, let's just track the number of times each character is mentioned across the entire book. Let me zoom into this plot. Okay, so what do we see? Who's the main character of this book? Can you tell? Joe, right? Okay. And we got that information without reading the book at all, right? So we didn't have to go in and read it. Just from a plot, we can see, okay, well, it looks like Joe is pretty important. Let's answer another question. So here we go. In chapter 32, Joe moves to New York alone. Her relationship with which sister suffers the most from this faraway move? Okay, so let's go back to the plot. Let's do this plot. This is the same plot, just a little different format. Okay, so in chapter 32, Joe moves to New York alone. Her relationship with which sister suffers the most from this faraway move? I don't have enough time to actually have you go to Menti and do this, but you can just look at this plot, try to see which sister. Yeah, you think?
Is it Beth?
It could be Beth. I actually would go with Meg here because it looks like Meg and Joe, they mention a lot, right? So they're mentioned pretty often together in each chapter. But then all of a sudden, Joe goes somewhere else, and then Meg is not mentioned much at all, and Meg stops growing. So that's what I would go with. Okay, last question before we go. Laurie marries one of the sisters near the end of the book. Which sister? Can you tell? So Laurie is the yellow line here, right here, Laurie. And he marries one of the sisters at the end of the book. Amy, right? Yeah, why do you say that? It's because we see that, oh, well, before like everyone's kind of mentioned scattered, but then all of a sudden, every time Laurie's mentioned, Amy is also mentioned together because people are like, oh yeah, Amy and Laurie went to the park. Amy and Laurie went to the county fair. So using data, we can get conclusions. We can draw conclusions without having to read the book ourselves by using a program. All right, that's it. Thanks for coming, and I'll see you Wednesday.